so in this video, we're going to be looking at the concept of work, energy, and power. We'll define their meaning, give examples, and solve practical problems involving work, energy, and power. Now, what is work? Work is said to be done when a force causes an object to move in a particular direction. So for instance, let's say I have an object. Let's say I have an object in this manner, and then I apply a force. I apply a force F. Force F to push this object to the right. Now, let's say after this application of force, this object moves to this distance. Let's call distance traveled by this object from here to this point. Let's call this distance simply S. Now, what is the work done? Work done is simply going to be the product of the force and the distance covered by the object. So mathematically, work done is simply equal to force multiplied by distance covered. And since work is associated with distance and distance is not displacement, this simply means work is a scalar quantity and not a vector quantity because work does not really have direction. So work is simply a scalar quantity and not a vector quantity. Now let's say we have an object inclined at an angle to the horizontal, as can be shown here. Let's say we have an object inclined at an angle theta to the horizontal. Now let a force either pull this object up the plane or let a force pull this object down the plane. So we simply say that work is said to be done when a force pushes an object a certain distance. So when an object is inclined at an angle, mathematically work done is given simply as the product of force and the distance covered by the object multiplied by cosine of the angle which it is made. So let's say this object was pulled a distance x, just like we explained earlier. So it means that the work done becomes the product of the force and the distance. But since this object is inclined at an angle, then you must be careful to multiply this work done by the cosine of the angle. So generally, work is said to be done when an object or when a force moves its point of application a distance in the direction of the force. Alright, now what happens when we have an object moved at a certain height? For instance, let's consider a man which is walking up a stair, as can be seen. Let's consider a man walking up a staircase, as can be seen in this diagram. Now, work is said to be done whenever a force moves its point of application a distance in the direction of the force. So you notice that this man climbs this staircase from this point up to this height. That means this man is doing work against gravity. Now keep in mind, if this man is standing at a spot, it is not doing work. But since it is moving itself from the downstairs up to the highest point of the stair, it means this man has done work. But this work now is directed against gravity, or is directed towards gravity, which is moving upwards. In that case, what this man is moving is not just the force that is compelling this man to move. What this man is actually moving through this height is its weight, because the weight is always directed towards the center of gravity. Recall we said earlier that work done, is given simply as a product of force and the distance covered. The product of force and the distance covered. In this case, the distance covered is the height of the staircase climbed by the man, whereas the force that compels this man to move is actually the weight of the man. Okay, it's actually the weight of the man, which is given simply as mass times gravity. The mass of the man multiplied by its gravity, that gives us the weight of the man. So the work done by an object in moving against gravity is simply due to the weight of that object and the height. So this simply means that work done in this situation is going to be what? Mass times gravity times the height of the object which this object is moving against. So basically, work is said to be done when a force moves its point of application a distance in the direction of that force. So when you consider work done against gravity, that distance becomes the height, and the force considered in this case becomes the weight of the object acting against gravity. Now let's say we are given a question that a 10 newtons force causes an object of mass to move 5 meters to the right. What is the work done? Simple. All you need to do is multiply the two of them together. This simply implies that work done is, remember, force times distance, and force is 10 newtons, distance is simply 5. That means the work done here is 50 newtons meter. Now it is important for you to know that the unit of work done is simply the newtons meter, which can also be called joules, because 1 newton meter is equivalent to 1 joules, right? So 1 newton meter is equal to 1 joule. So the unit of work can either be newtons meter or it can be simply joules. Now let's say this object is inclined at an angle of 30 degrees to the horizontal. So we have something like this. We have an object inclined at 30 degrees and we have a force of 20 newtons trying to pull this object up the plane, covering a distance of 5 meters, and the angle to the horizontal is 30 degrees. We have an angle here which is 30 degrees. What then is the work done? Remember, whenever the object is inclined at an angle, work done is simply going to be equal to the product of the force and the distance and the cosine of that angle. So this simply means that in this situation, work done is equal to force given in the question is 20, distance itself covered is 5 meters. So you have 20 times 5 multiplied by the cosine of the angle, and the angle in this case is 30, so you have multiplied by cos 30. So this simply implies that work done is going to now be equal to, so simply obtain 20 times 5 times cos 30, and that gives us approximately 86.6 joules or newtons meter. Okay, so you have 86.6 newtons meter, or simply 86.6 joules. All right, now let's say we have an object of mass at a certain height. Let's say we have an object of mass 5 kg. Okay, let's say we have an object of mass 5 kg suspended at a certain height from the ground, and let this height be 3 meters. Okay, so this object is basically thrown from the ground to the top at this height, 3 meters. What then is the work done? From what we explained earlier, remember, work, when an object is acting against gravity, it means the work done in that case becomes gravitational work done, and that work done is as a result of the weight of the object, and that is going to be equal to mass times gravity multiplied by the height covered by the object. So this is going to be equal to the mass given to us in the equation is simply 5 kg multiplied by the gravitational, of course, gravitational acceleration is constant, which is 9.81. So multiplies 9.81, multiply now by the height covered, which is 3 meters. So this simply gives us the work. So whenever work is directed against gravity, that work is a function of the weight of the object and the height covered. So let's get this product and see. So simply we have mass, which is 5, times height, which is 3, multiply gravity 9.81. That simply gives us 147.15 newtons meter. So we have 47.15 newtons meter. So this becomes the work done by an object thrown from the floor to a height of 3 meters against gravity. Now let's take a look at the concept of energy. I think it's almost time for class. So the next time we'll talk about is the concept of energy. Now, energy is simply what enables work to be done. By definition, it can be defined as a capacity or ability to do work. So when a man is pushing an object, then it means that that man has actually done work by pushing that object from one position to another. But what gives the man the capability to do such work is called what? Energy. In the same way, if you want to lift an object from the ground to your head, you have done work by lifting that object to your head. But what gives you the ability to do that work is called what? Energy. So which means energy is actually what? Inbuilt. Now, there are different forms of energy. We have mechanical energy, we have electrical energy, we have renewable energy, we have chemical energy, we have petrochemical energy, and so on and so forth. But in this video, we are going to be focused mainly on mechanical energy. And there are two basic types of mechanical energy. One, we have the potential energy, and then the second, we have the kinetic energy. Now let's look at these two basic types of energy in details. Now let's talk about potential energy. Potential energy is simply the energy possessed by a body by virtue of its state at rest or at a certain height. So this means that an object must be at rest and at a height to actually exhibit potential energy. So if I have an object, let's say I have a block. Let's say I have a block of mass m, which is actually positioned at a certain height from the ground. Okay, and let this height be what? H. Now this block has the potential of rolling down and shattering a glass just on the floor. Why? Because at this certain height, this block of mass m has gathered what is called a potential energy. So it is that energy with which, if it falls off from this height, it is going to use to shatter a glass on the floor. So an object must be at a certain height, one, and then the object must also be at rest before it can possess potential energy. Now, mathematically, potential energy can simply be given as the product. Potential energy is simply given as mass multiplied by gravity multiplied by the height of the object. The mass of the object multiplied by gravity multiplied by height, and it is measured in joules. Potential energy is simply measured in joules. Now, it is important for you to know that potential energy is actually a function of the weight of an object and the height of the object. So since it's a function of the weight of the object, it is fair to say that potential energy of every object can also be called the gravitational potential energy, since they depend on what? Gravity, because the object must be at a certain height against gravity. Alright, now let's say that this object has a mass of 10 kg. Let's say this object has a mass of 10 kg, and let's say this object is at a height of 4 meters. Let's say this object is at a height, let's say this object is at a height of 4 meters. Now, what becomes the potential energy? See, this simply means that potential energy, okay, is going to be equal to the mass of the object is 10 kg, so you have 10 multiplied by the gravity. The gravitational acceleration is a constant value of 9.81 multiplied by the height of the object is simply what? 4. So if you multiply this all through, you obtain the potential energy. Potential energy is going to be equal to, now let's find 10 multiplies 9.81 multiplied by 4. So this simply gives us 392.4 joules. So we have 392.4 joules. So this becomes the potential energy possessed by an object of 10 kg mass, which is at a height of 4 meters. Another type of energy to be considered is the kinetic energy. Kinetic energy is energy possessed by a body by virtue of its motion. So when an object is in motion, what it possesses is simply called what? Kinetic energy. So in potential energy, an object must be at a height and that object must be at rest. But in kinetic energy, that object must constantly be in motion before it can possess what is called the kinetic energy. So every moving object, like a vehicle that is moving, possesses what is called kinetic energy. Alright, now mathematically, kinetic energy can simply be given as kinetic energy equals 1 all over 2 mass times velocity all squared. So this is the formula for kinetic energy, and the unit is also what? Joules. So kinetic energy depends on the mass of the object as well as the velocity of the object. So let's say an object has a mass of 5 kg and this object is moving with a velocity of 10 meters per second. So it means that the object has kinetic energy of what? This is going to be 1 all over 2 multiplied by the mass of the object is 5 kg multiplied by the velocity of the object is 10 to the power of 2. So if you do all of this together, you're going to find the kinetic energy possessed by the object. And everything here simply gives us 250 joules. So you have 250 joules. So an object of mass 5 kg moving with a speed of 10 meters per second actually has 250 joules of energy in it. Now, it's important for you to know that energy can actually be transferred from one form to another. So it can be transferred from kinetic to potential. It can also be transferred from potential to kinetic. Now, this process can be achieved via the principle of conservation of energy. And what is the principle of conservation of energy? Now, the principle of conservation of energy simply states that in a closed or isolated system, the total energy on a system is conserved, but it can be changed from one form to another. So remember earlier I mentioned about transformation of energy. That is simply changing energy from potential to kinetic or vice versa. And I also said that transformation depends on the principle of conservation of energy. Now let's consider this image to illustrate the principle of conservation of energy, as well as illustrating energy transformation. Now taking a look at this image, you have an object at a certain height. At this height, this object is not in motion, this object is at rest. Since this object is at rest and not in motion, and it is at a certain height, it means that this object possesses what? Only potential energy at this point, because potential energy is the energy possessed by an object by virtue of its state at rest and at a certain height. But since this object is at rest and not moving, it means it does not have kinetic energy. So at this position, kinetic energy is 0, and the maximum energy which we have here is simply what? Potential energy. Now let's say this object falls a certain height, as can be seen here. Let's say this object falls a certain height. Now, since this object exhibits motion from falling from this point to this certain height, it means that this object has kinetic energy. But again, this object is at a certain height at this point, which means this object also possesses what? Potential energy. So it means that at this point, at this particular position, the total energy possessed by this object here is both potential energy and what? Kinetic energy. This becomes total energy possessed by this object. Total energy. That becomes the total energy possessed by the object at that point. Both kinetic energy and potential energy. But when it is at the top, it is only what? Potential energy that it contains. because kinetic energy is simply equal to what? 0 at the top. Now, when this object finally gets to the floor, at the floor it is at rest, but it is important for you to understand that at this floor, this object does not have what? Height. It means that the height of the object at the floor is 0. And since the height is 0, it means that this object does not possess potential energy, even though it is at rest. It has potential energy, but its potential energy is what? 0. Now, since potential energy is 0 at this point, which is at the ground, then it means it only possesses what? Kinetic energy. So at the ground, potential energy is simply what? 0. So I have potential energy to be equal to 0, but then I have kinetic energy existing there, which is simply what? 1 all over 2 mv squared. So you see how this energy has transformed. First, it was potential and kinetic energy 0, and then next it transformed into both potential and kinetic energy. Next it transformed into what? Only what? Kinetic energy. In all of these things, energy have been transformed from one form to another, but then it is what? It is simply what? Conserved. The energy is simply conserved. So this is the principle of conservation of energy as well as energy transformation. Now let's consider this question to explain the concept of conservation of energy. We are given that a 5 kg ball is released from a 20 meters height. What is the velocity of the ball as it reaches the ground? So let's pick at our parameters. We are given mass to be equal to 5 kg, right? And we are given height of the ball to be 20 meters. We are actually asked to find the velocity. V is unknown. Now, we talked about the principle of conservation of energy earlier. I also mentioned the idea of energy transformation from either kinetic to potential or vice versa. Now, the principle of conservation of energy simply states once again that in a closed or isolated system, total energy in a system is simply conserved, although energy may change from one form to another, which talks about transformation. So, from the idea of energy transformation, which we mentioned earlier, we talked about an object at a height, and we said if an object is at a height, it means that object possesses what is called potential energy. But when that object is released from that height, that potential energy is actually being transformed into what? Kinetic energy, because now that object is set into motion. So that simply means in the case of this question, an object is released from a 20 meters height. So which means when the object is at height, the energy possesses what? Potential energy. But when released, this potential energy turns into what? Kinetic energy. Now, what is the formula of potential energy? Remember, mass times gravity times height. So this is equal to, what's the formula for kinetic energy? Remember, 1 all over 2 times mass times v squared. So from here, it's safe to say mass can easily cancel what? Mass, because the object has what? Equal mass. So the two masses can cancel out. So which means what we have left is simply what? Gravity times height being equal to 1 all over 2 v squared. And we are asked to find velocity. So we simply make velocity subject of the formula. Now, but before doing that, let's multiply both sides by 2 just to eliminate this 1 over 2 over here. So this means v squared is actually going to be equal to what? 2 multiplied by gravity multiplied by height. So you see how easy this is. From here, we can find our velocity. So this simply implies that velocity is simply equal to, is going to now be the square root of 2g times h. So you simply what? Plug in your values in this case to find velocity. Velocity is simply going to be, so we have our v to be equal to the square root of 2 multiplied by, remember g, gravity, at the secondary level, gravity is actually taken as 10, so you may consider it as 10 at the secondary level, but at the higher institutions it's taken as 9.81, but let's take it as 10 here. Now, the height given in the question, remember, is 20 meters high. So this is actually going to be what? The square root of, let's obtain 2 times 10 times 20. That simply gives us 400. That simply gives us 400. Therefore, the value of velocity becomes, let's find the square root of 400. And the square root of 400 simply gives us 20. So it means that the velocity of the object is 20 meters per second. Alright, so for that given question, its velocity is simply 20 meters per second. Now, having discussed the concept of work, the concept of energy, and the two forms of mechanical energy, let's now talk about power. Now, let's talk about the concept of power. Power is simply the rate at which work is done. It is simply the rate at which work is done. By that definition, it means that power is simply work done within a specific time. Mathematically, power can be represented as P, and this is equal to work done all over time. It is the rate at which work is done, and its unit is joules per second, which can also be called watts, because 1 joules per second is equivalent to watts. So the rate at which work is done is simply called power. Quickly, we are going to pick an example to actually explain this. Now, let's consider this question. It says, a boy weighing 30 newtons falls from a height of 7 meters in 5 seconds. What is the power of the boy? Now, let's pick at our parameters. First, we are given the weight of this boy. Weight W is given as 30 newtons. Now, he falls from a height of 7 meters. So you're given height h, which is actually 7 meters, and then you were given time when this thing happened. Time t was given as 5 seconds. Now we are asked to find the power exhausted by the boy, the power available, the power utilized by the boy. Now, first you recall that power is actually work done all over time. Okay, work done divides by time. But then, what is work done? You remember that work itself is force times distance. So you have work to be force times distance all over time. But what then is force? This boy is falling under gravity. That means the force possessed by this boy becomes the weight of the boy. Okay, so this means that power is equal to, since this boy is falling under gravity, it means the force possessed by this boy is actually the weight of the boy. So you have power to be what? This becomes, in place of force becomes the weight of the object multiplied by what? Distance. And in this case now, distance becomes the height and not just distance. So in place of x, we simply have what? Height all over time. So this is going to be equal to, the weight of the boy is 30 newtons. So you have 30 multiplied by height covered is 7 meters divided by the time is 5 seconds. So this is going to be equal to, let's obtain 30 times 7 divided by 5. And that simply gives us 42 joules per second, or simply 42 watts. So you have 42 joules per second, which can also be called watts. So that is the power possessed by that boy. Now, in the next video, we are going to be solving random questions involving work, energy, and power. I'm sure you want to be a part of that video, so do well to strike the subscribe button right now and turn on your notification bell so you don't miss out on that video when it drops. Please do well to like this video, share to your friends, and comment nicely. I will see you in the next video. Thanks.